steps and how to implement authentication in your client application based on the OpenID Connect protocol. So first up, I will review some of the reasons for adopting OpenID Connect for your authentication protocol. I'll talk briefly about JSON Web Tokens, or JWTs, so that you understand their role in the security protocols and what is in them. Next, I'll review the different authentication flows that are defined as part of the OpenID Connect protocol, and we'll talk about which kinds of applications should choose which flow. I'll cover some considerations about the client library you choose and why you might want to use OIDC Client. I'll then go through some demos to help you get the client and server sample code for the course up and running on your machine. After that, I'll dive into coding in earnest. I'll add OIDC Client to the Angular app and create an Angular service component to encapsulate the authentication functionality in the client app. Then I'll step through getting the client configured to connect to my STS with the appropriate settings to let my client app use it as its security authority. Next, I'll add the UI and logic to get the app to redirect to the STS to start the login flow. After that, I'll show how to handle the login callback to complete the sign-in process with the STS. Once I've got login working, the next logical thing to do is make sure the user can log out properly. So I'll step through adding the appropriate code to complete the logout process. Finally, I'll wrap up this module with some tips for debugging that you will want in your toolbox, specifically diagnosing client configuration errors and inspecting JWT tokens to see what the STS is returning to the client. For brevity, I will often refer to the OpenID Connect identity provider as simply the IDP or STS for short. Both terms are essentially equivalent. Likewise, I'll use OIDC as an abbreviation and a quicker way of saying OpenID Connect. So let's start by talking about why you might want to adopt OpenID Connect for your client application authentication. As discussed in the first module, adopting OpenID Connect implies a little different architecture than you may be used to if you have only worked on building single websites that handle their own authentication. OpenID Connect is based on the idea that you will have an identity provider, also called IDP for short, that is responsible for authenticating your application users and issuing them ID and access tokens for authenticating and authorizing access to your backend APIs. Even though this implies a slightly more complicated architecture and setup for your application, doing so has a number of important benefits as well. First off, you end up with a more decoupled system. Since all of the authentication, logging in, collecting and validating credentials, and issuing an access control token happen outside of your application code, that lets you focus more on the business functionality of your app instead of needing to weave in a bunch of plumbing code for security. As mentioned in the last module, most apps will still have some degree of access control or permissions that are specific to the app, and therefore should be handled by the application code itself, not the identity provider. But the lines of separation there end up much more clean than when the app has to handle everything itself. Another big benefit, and one of the primary motivators for a lot of companies, is that you enable single sign-on scenarios, where one-to-many apps can share the same identity provider. And that means as a user moves from app to app, not only don't they have to keep track of a bunch of separate sets of credentials, they only need to log in once, and their authentication session can flow from app to app as they move between them. Finally, because you end up having most of the authentication-related functionality in the IDP, that means you will also have centralized credential management. So your IDP becomes your one-stop shop for provisioning users and managing their accounts and high-level access control. Now let me quickly cover a few more details of the OpenID Connect protocol that you should be aware of. There are some aspects of the protocol that are the same regardless of what kind of app you are building. Those include the use of the JSON Web Token, or JWT, pronounced JOT, format for tokens. JOT tokens encode a collection of claims, which are just key value pair pieces of information about the user, the client application, the identity provider, the protected resource, and the protocol itself. JWT tokens are digitally signed using cryptography so that they cannot be tampered with after they have been created by the identity provider. But they are not encrypted, so anyone who can get their hands on the token can view its encoded contents. The two tokens that will be issued as part of the OpenID Connect authentication are an ID token, which contains information about the authenticated secure session for a user or client app, and an access token, which is based on the auth2 protocol. I'll go into more detail on access tokens in the next module when we're focusing on authorization and access control. Part of the process of generating tokens and validating those tokens at a relying party requires cryptographic keys to digitally sign the tokens and to validate that signature. So storing those keys appropriately is one of the considerations in choosing which protocol flow to use for your app. OIDC defines three different flows, which are basically sequences of operations and messaging that lead to an end result of a user or client application being authenticated with the identity provider. The end result of an OIDC flow is an ID token and auth2 access token for the user and the client application to access the requested resource, such as a particular API or web application that is protected by the IDP. These flows include authorization code flow, hybrid flow, and implicit flow. For any given app, you will only be using a single flow, but realize that each app that is connected to an OpenID Connect provider can be using a different flow from other apps when the server is acting as a single sign-on server for multiple apps. The first flow of OpenID Connect, and the one we'll be using throughout the course, is the authorization code flow. This flow involves redirecting the user to a login page at the STS, and then redirecting back to the client with an authorization code after successfully validating the user credentials. Then the client app makes a request to the token endpoint at the STS, passing the authorization code and obtaining the ID and access token in the response. I'll go into more detail on this flow shortly. Another flow in the OIDC protocol is hybrid flow. This flow starts the same as authorization code flow, but also involves obtaining a token for the end user on the back end for calling out to downstream services or APIs on behalf of the user. The third flow is called implicit flow. Until early 2019, implicit flow was the recommended flow for single-page apps or JavaScript client apps, which obviously includes Angular apps. It was not recommended to use authorization code or hybrid flow because of certain security threat models that had more significant vulnerabilities for client-side code than implicit flow had. In fact, the initial release of this course in mid-2018 only covered implicit flow as the recommended approach until I updated this course in mid-2019 due to new guidance from the Security Standards Group that owns the OpenID Connect and auth2 standards. The change came in the form of two new guidance documents from the Internet Engineering Task Force, or IETF, one named OAuth 2.0 Security Best Current Practice, and the other is OAuth 2.0 for browser-based apps. These documents included new and updated guidance around the OpenID Connect and OAuth 2 standards that were partially driven by the widespread availability of support for CORS and same-site cookies in the current browsers of 2019, which could not be relied on back when the OpenID Connect protocol first came out. The switch from recommending implicit flow to authorization code flow for JavaScript client apps was also heavily influenced by a new related standard for OIDC and OAuth named Proof Key for Code Exchange, PKCE, pronounced PIXE for short. This was originally designed for native apps, but ended up being great for JavaScript client apps and mobile apps too. At a high level, Pixie provided mitigation for a vulnerability introduced when returning an authorization code to a public client, which includes JavaScript client apps because the code can be viewed and modified in the browser. The vulnerability had to do with the fact that if someone could intercept the URL of the redirect back to the client app, they could use the authorization code with other clients to obtain tokens for them as well. With Pixie, the client generates and hashes an additional code that it sends with the authorize and token endpoint calls to make it so only the current client can use the authorization code sent back by the STS. By switching to authorization code flow with Pixie, you avoid one of the threat models that implicit flow had. This threat model was related to the way the ID and access tokens that the STS returns were placed in the redirect URL as a hash fragment. This made it possible for someone with access to the computer to steal an access token and use it with requests from a totally separate client, even on a separate machine, until that token expired. This was not a big threat because a well-constructed app could minimize the opportunity for token theft in a number of ways. And it did require being able to intercept the URL used for the redirect to the client after login. But with authorization code flow with Pixie, that threat goes away. As a result, the guidance as of early 2019 is to not use implicit flow for web, mobile, or native client apps, effectively deprecating the implicit flow. Instead, authorization code flow with Pixie is the way to go. Because the threat model for stealing the tokens from the redirect URL and implicit flow is not a big one, and since the guidance to use implicit flow for JavaScript client apps has been in effect for over 5 years as of this course update, I'm sure there will be many apps out there for a long time to come using implicit flow and not having any security breaches because of it. And as a result, you probably don't need to rush to change your implicit flow apps to authorization code flow with Pixie. But if you are using a good STS like Identity Server and a good client library for the protocols like OIDC Client, it only requires a simple change to config that I'll cover in the demos to switch to authorization code flow with Pixie from implicit flow. Next, let's take a look at exactly what's involved in the protocol flow for authorization code flow with Pixie.
पहले से ज़्यादा मानदान बढ़ गई है ना, मानदान बढ़ गया पहले से, अब हमेशा अपने सामने ही रहा था।
I think it is worthwhile to show a diagram of what is happening during the authentication process with the STS when using authorization code flow with Pixie. The process starts with the client application or user deciding they need to be logged in. I say the client application here because if you use something like Angular route guards, as I'll show in the last module, It could be the application code that decides, based on the client route that's being navigated to, that the user needs to be logged in to see that view. Or, of course, it could be explicit user action by clicking a login button or link if parts of your Angular app can be used without logging in. The first thing that happens when using Pixie is that the client app generates a code verifier. It then uses a crypto algorithm to generate a hashed version of the code verifier, which is then called the code challenge. The client then needs to redirect to the STS's authority URL, passing the code challenge in that call. The STS will hold on to the code challenge associated with that client, and then will take care of loading the login page if the user does not already have an authenticated session with the STS. The user then enters their credentials in the login page. When that login form gets submitted to the STS, the user credentials are validated, typically by looking up the entered username and password in the STS database or storage. As long as the credentials are valid, the STS then redirects back to the client app using the redirect URL that was part of the client's configuration at the STS. In that redirect, the authorization code will be provided to the client in the redirect URL. The client then calls the token endpoint of the STS as an API call, not a redirect, passing the authorization code and the code verifier. The STS can then apply the same hashing algorithm to the code verifier and compare the result with the code challenge that was sent by the client at the beginning of the process, which ensures that it is the same client using the authorization code as it was intended for. The token endpoint call returns a payload containing the ID and access tokens that the client needs to call the approved resources, which are identified by the scopes configured for the client and returned as claims in the access token. So as you can see, there's a lot going on there that you wouldn't want to have to code up yourself. As you'll see in the demos, getting this all working with OIDC client is very simple and straightforward. Stuff is pretty complicated, which is all the more reason you should not try to implement it all from scratch yourself. The last thing you want is for your app to be the next news headline about a data breach and potentially millions of user accounts compromised. That's why I'll be using the OIDC client library for implementing the code needed in your Angular app. This library sometimes gets criticism for being heavyweight. The minified version of the library weighs in right around 370 kilobytes, uncompressed. Most of this is not the code of OIDC client itself, but the cryptography libraries that it depends on. Is this heavyweight? Well, compared to a lot of single-purpose JavaScript libraries out there, it's a little heavy. But so is the burden of getting security correct. If you compare the size of the main bundle of a production build of an Angular Hello World app with no other library dependencies, that is about 210 kilobytes with Angular 8. But of course, to build anything real, you'll typically need to bring in a bunch of other libraries for UI components, working with dates, theming, and so on. So it's not uncommon for your app bundles to be anywhere from 1 to 20 megabytes in size. So when you put that 370 kilobyte OIDC client library in that context, it's not so heavy after all. Besides, Angular is not really designed for content-centric websites where users get in and out quickly and don't spend significant amounts of time in the app. It's really designed for highly interactive and engaging apps that users spend significant time working in. So while the size of the bundles can get pretty big for an Angular app, always remember the user should only pay the download penalty for that size once for each release you publish. After the browser downloads those bundles, it caches them and loads them from the cache unless it sees that the source has changed on the server side. So it's not like you will be downloading those libraries over and over every time the user fires up your app. And again, it all comes down to two crucial points. Security protocols are very complicated, and getting security right is critical to the success of your app and your business. So my recommendation is to not get hung up on the size of OIDC client. It will probably be dwarfed by the rest of your application, and the download cost is worth the assurance that you're using a certified protocol compliant library for implementing those protocols, which will better protect your users, your application, and your business than a home-baked approach. So now you know the big picture concepts of OpenID Connect. Now let's get started putting it to use in our sample application. As a starting point for the demos in the rest of the course, I'll be using the same sample application I showed at the end of the last module, but without any of the security-related code hooked up. Over the rest of the course, I'll add that code in incrementally, explaining each bit as I go, and showing some of the options you have to do things a little differently depending on your requirements. If I fire up the app at this point, I land on the home page as before, but I can go into the My Projects view and see all projects, regardless of who is using the app, because at this point, the app can't know who's using it without authentication. And the backend cannot filter the list of projects it returns because it has no idea who the caller is either. If I select one of the projects, I can go into its detail view, which shows a list of milestones. Again, I will constrain whether the user can edit or view the project later in the course, but at this point, anyone can add, edit, or delete milestones. If I go into the Manage Projects page, this is the one I'll want to constrain to only admins. Here, they can create or delete projects and manage what permissions users have to access or edit the project. But again, at this point, anyone using the app can go exercise that functionality. Starting to modify the code is to make sure you can run the client application on your local machine. I've created the Angular app for this course using the Angular CLI, so it has everything you need. You just have to make sure you have Node.js installed on your machine. If you do not, go to nodejs.org and download and install the LTS version of Node for your machine. You will also need the Angular CLI installed on your machine. To do that, open a command prompt or PowerShell window on a Windows machine or terminal on a Mac and run npm install -g @angular/CLI. Once that's installed, you need to restore the packages for the client app. So at the command line in the root folder for the client project, run npm install with no arguments. This will install all the packages referenced in the package.json file, along with all their dependencies, into the node_modules subfolder. If you see some warnings, don't worry, that's normal. Once that's run to completion, you can start debugging for the app by running ng-serve. This will build the client app, start up the Webpack dev server to serve up the code on port 4200 by default, and will also set up a file system watcher to rebuild the app anytime it sees one of the source code files has changed. Once it finished that process, you can open a browser and navigate to localhost 4200 to see the app running. The client code is configured to use cloud-hosted instances of the API and STS so that you do not need to set up and run the back end to work with the sample code if you don't want to. But if you do want to get everything running locally, let me cover getting the back-end code running locally as well. It includes both the client-side code that I will be mostly focusing on, but also includes the back-end APIs for the app, which are implemented in ASP.NET Core, and an Identity Server 4 project for running the STS locally. I've deployed a version of this code to the cloud, and the client code is set to point to those cloud services, so you don't need to set up any backend on your machine if you don't want. But in case you want to follow along and run everything locally, let me show you what you need to do to set up the backend API and Identity Server 4 STS. If you're completely new to Visual Studio, ASP.NET and/or SQL Server, just stick to running against the cloud-hosted versions of the code. This course is not meant to teach you how to build APIs or how to build an STS using Identity Server. But let me run through the steps quickly for those who are familiar with .NET development. To do this, you will need a recent version of Visual Studio on your machine. You can use the Community, Pro, or Enterprise versions, or you can use the .NET Core command line tools. I'll use Visual Studio Enterprise here. The first step is to get the databases in place. For that, I've included a SQL script named initdata.sql that is in the root folder for the demo code. The connection strings in the backend code are configured to use the local DB instance of SQL Server that gets installed with Visual Studio. You'll also need SQL Server Management Studio on your machine or know how to run SQL scripts from a command prompt. So you can open the initdata.sql script in SQL Server Management Studio, connect to the local DB instance with Windows authentication, and then execute the script to create the two databases needed, one for the application API and the other for the Identity Server STS. Once you have run that script, you should open the Securing Angular Apps.api solution in Visual Studio. To minimize configuration issues, I recommend running the projects as console apps, which I'll show how to do here. First, select the API project in Solution Explorer. Right-click on it and select Set as Startup Project. Up in the debug toolbar, drop down the arrow next to IIS Express and select the API project name. This will configure that project to run as a console app on your machine. Then repeat those steps to set the STS project to run as a console app as well. Once that is done, let's get things set to run both projects when you start debugging. To do that, right-click on the root solution node and select Set Startup Projects. In the dialog that pops up, select Multiple Startup Projects and then select Start next to each of the projects. Click OK to complete that, and then you can click on the Start button to get both up and running attached to the debugger. Now you should be ready to run against the locally running API and STS. So you would just drop into this constants file on the client side, comment out the lines that configure connecting to the cloud versions of the services, and uncomment the lines that replace those with the localhost configuration. So the first step in adding the ability to log in with an OpenID Connect identity provider is to have a client library that handles the protocol level details for you. Again, I'll be using OIDC client here, so let me get that installed into the project. To do that, I just run the following in the root folder for the client project: npm install oidc-client-save. Again, you'll probably get some warnings like I did here, but you can generally safely ignore them. For all the demos in this course, I'll be using Visual Studio Code for the client-side coding, which I'll call VS Code for short. This is just a preference, of course. Whatever editor you prefer for working on your Angular code is fine. If you want to learn more about Visual Studio Code, I recommend you check out the course Visual Studio Code by John Papa. To get started, I need somewhere that I'm going to manage the overall security context for the application. So let me add a file here to the core subfolder, and I'll name it auth-service.component.ts. I've got John Papa's Angular code snippets set up as an extension in VS Code, and they make adding the boilerplate code for different Angular constructs fast and easy. You could also use the Angular CLI's built-in schematics or templates to generate a service component for you, but I'll stick to using the code snippet here to keep things minimal. So I'll type a dash here and see a list of the available snippets in John Papa's Angular Snippets extension. And I'll select the service component that does not use HTTP client, because OIDC client will be making the calls for us. As you can see, the code emitted by the code snippet is pretty minimal, but at least has the basic structure and imports. I'll add the provided in property on the injectable decorator and point it to my core module. Next up, I'll add and configure the OIDC client user manager that will do the hard work of authenticating with OpenID Connect for us.
तो अपना ऑर्डर का थीम रहता है जा रहा है अभी तो नहीं पूछना बस सेटलमेंट नहीं हुआ ना कि आइटम अवेलेबल नहीं
Client, the first thing I'm going to add in here is an import statement for the user manager and user types from that library. These are the primary types you'll deal with from OIDC client. Next, I'll add a private property of the type user manager and also a property for the user type that user manager will produce at the completion of the login process. The user manager object manages all the low-level protocol details of the OpenID Connect flows for you. So you don't have to worry about what is going on at a wire level between your app and your identity provider. And the user type encapsulates the client-side info about a signed-in user, such as the ID and access tokens returned from the identity provider, any user profile information exposed by the IDP as claims, and being able to tell when the tokens for the user are expired. I'll create an instance of the user manager in the constructor for the auth service. And you can see from the autocomplete pop-up that it requires a settings object. This can just be a JavaScript object literal and can contain a variety of settings related to the identity provider you'll be connecting to. Some are required, some are optional, and the values for these settings will be driven by the configuration and capabilities of your identity provider, as well as which protocol flow you choose for your clients. For most of the demos in this course, I'll be using Identity Server 4 as my identity provider. Since I'll be using authorization code flow with Pixie for my Angular client app, there are just a few settings required in the object you pass to User Manager. The first is the authority URL. This is typically the root URL for your identity provider. If you're running the sample code for the backend locally, the value you'll want to have for the STS will be HTTP localhost 4242, based on the port that the STS project is configured to run on. If running against my cloud deployed version of the code, then it's HTTPS securing Angular apps course v2-sts.azurewebsites.net. Here, I'm just using a constants file that holds the URLs for the app so they are easy to switch in one place. You could also handle these settings using the environment files that Angular supports. I'll just stick to a simple constants file here and comment out the ones I'm not using. You can also see here I have a client root URL and a client ID configured in my constants file. I'll use those in just a moment. So back over here in my auth service, I will set the authority property on my settings object to use the STS authority constant. By the way, I'm using an extension to VS Code called TypeScript Hero that automatically adds import statements to the top of the file for you the first time you use a type within that file. So here it added the import statement for constants when I tapped to accept that type name from the autocomplete list. Next is the client ID. This is an identifier that will be used to match your client app against a client configuration at the STS. This is determined by the identity provider you're working with. With Identity Server, these are just string names that you can set in the configuration in code, app settings, or the database. For my demos in this course, I named this spa-client. Note that as far as the STS is concerned, it doesn't care what technology your client is implemented in. It just needs to know the settings for it as an OIDC client. So I set the client ID property of my settings object to the client ID I set in my constants file. Next, you need to configure what URL the STS will redirect to after the user authenticates with the STS. You could have it redirect back to a separate HTML page outside of your Angular app's root page. But in most cases, it is more convenient to just set up a custom route in your Angular app that completes the sign-in process and then navigates to whatever view is appropriate using Angular routing when the sign-in process completes. So I'll set the redirect URI property to a route of sign-in-callback off my client app root URL, and we'll add a view component for that in a little bit. Next, you need to identify the scopes that your app requires. As mentioned before, think of scopes as high-level access control identifiers for a back-end resource, such as an API endpoint that your app requires access to. It is again part of the STS configuration for the client to identify which scopes should be allowed for each client app. You'll always need the OpenID scope when using OpenID Connect, and the profile scope is optional. Next, I need the scope that is associated with my project's API, that is the backend for this app. If the client asks for scopes that are not configured for that client app at the STS, you'll get an error when you attempt to log in, indicating the client has an invalid client configuration due to unauthorized scopes. Next, you need to set the response type that you need. For authorization code flow with Pixie, this will just be code. In implicit flow, the response type has two values, ID token and token. This is the only indication or change in the client configuration for authorization code flow versus implicit flow. So if you had an existing client that was using implicit flow, you would just change that response type setting to code as shown here, and you would be done with the changes on the client side. Of course, you would also have to change the client configuration at the STS to also switch to authorization code flow with Pixie instead of implicit flow. Finally, you should configure a post-logout redirect URL. This is where the STS can redirect you to after you redirect to the STS to log out. Remember that both login and logout have to happen at the STS because that is where the lifetime and granting of the tokens happen. You'll want this URL to be something you can route to a view component to complete the login process. I'll end up adding a view component to handle this route as well. So now I have a user manager instance configured and ready to go. Next, I'll add a login button to the page and get to the point where I can log in at the STS.
और इन बतिया रहे पूरा दादी खाने बतिया है तो जानते हैं फोन फैल गए तो सब आदमी के एक ही आवाज सुनाई.
Now that I have a user manager to work with, I can now set up our first login. User manager makes this easy for us. You don't have to know exactly what the requests to the STS need to be. You just ask user manager to do the right thing. That involves getting redirected to the STS to log in, and then getting redirected back to our app with an authorization code. Then the user manager calls the token endpoint of the STS with the authorization code to exchange it for ID and access tokens. When using Pixie, the user manager will also take care of creating the code verifier, hashing it to create the code challenge, and will send those in the appropriate requests to the STS. So all I need to do to cause the first redirect is to ask user manager to do that for us. So I'll add a method named login to my auth service, and in there I will call usermanager.signinRedirect and return the promise that comes from that method. I'll also want to have a way that any code in the app can check to see if I'm already logged in. After a successful login, user manager stores in session storage the resulting user object that it creates, so that it can be retrieved anytime it is needed, such as to get the access token to send to your API calls. The user object contains the ID and access tokens, as well as an expired flag you can check to make sure the access token is not expired. So I'm going to add a method to the auth service called isLoggedIn, and I'll have it return a promise of Boolean. In there, I'll first call getUser on the user manager. This returns a promise that produces a user object. In the promise handler for that call, I'll check to see if the user I got is not null and not expired. Then the method can return true or false, depending on whether I have a valid user object. When the redirect comes back into the Angular app from the STS, the process that obtains the ID and access token happens asynchronously from the loading of the root view. So I'll also need to raise an event when the user is loaded so I can update any UI that depends on that. I'll use an RxJS observable to do that. So I'll declare a private property on the auth service that is an RxJS subject, and then a public observable that is produced by that subject. Then I'll add code to fire that observable here in the isLoggedIn method. I'll also end up firing that observable when the login process completes, but I'll get to that in a little bit. Keep in mind that if the user goes and loads a different site in the browser tab your app was loaded in, and then they come back to your app, it will be a fresh load of the application. This is also the case when the user gets redirected to the STS and back again as well. So I'll go add an isLoggedIn check to the root app component so the user gets loaded on launch if there's already one in session storage from a previous login. To do that, I'll inject the auth service in the constructor of the app component, and then I'll add an isLoggedIn property to that component. Then I'll set that property by calling the auth service isLoggedIn method from ng-on-init. I'll also add an event handler to update that property when the logged in status changes. Now I need to go add a login button and call login on the auth service when it's clicked. So let me go to the app component UI markup that sets the menu for the app and add a login button in the upper right with a click handler that calls the login method on this component. Then I need to add that login method that the button click calls to the app component. In that method, I just need to call the authService.login method. The authService login method does return a promise, but there's rarely a reason to handle it because calling sign-in redirect on the user manager is going to result in a redirect to the STS immediately, which means your app will be unloading from memory anyway as soon as that is called. At this point, our code should be ready to log in. So let's fire it up and take it for a drive next.
देख ले हमरा के भेजे वाला तोरा के नहीं भेजा ना क्या करना है मुझे हां So now I have the code in place to get us redirected to the STS to log in. Let's run it and see what happens. To run an Angular CLI project, you just need to drop to the command line in the project root folder and run ngserve. Once the CLI has finished building your app and launches a web development server, I can go load HTTP localhost 4200 in the browser. After the app loads, let me go fire up Fiddler so we can take a look at the requests and responses for the OIDC login flow. If you're not familiar with Fiddler, it's a great and free wire-level tracing tool that lets you inspect and create raw requests and responses that are happening from your machine. And it gives you a lot more context about the calls than you get in the browser debugger. Now, if I click on the login button, after a moment I end up on the login page for the identity provider. There are actually several requests that happen behind the scenes in getting us there. When you call sign-in redirect on the user manager, it makes a request to this .well-known/openid-configuration address on the STS. That is part of the OIDC protocol, specifically an endpoint you can get to get metadata about the STS. You can go hit that address in the browser directly, and you can see it's just returning some JSON that contains metadata about the public settings of this server for its support of the OpenID Connect protocol. After that request, you can see it makes the request to the authorized endpoint of the STS,
passing as query string parameters the configuration that was set for the client, including client ID, callback URLs, the requested scopes, the code challenge for PKCE, and a few other pieces of data that are part of the OpenID protocol. The authorized endpoint then redirects to the login page to let the user enter their credentials. If any of the parameters passed to the authorized endpoint do not match up with the client configuration or registration at the STS, you'll get an error here, and you would have to look in the logs on your STS to figure out what the specific issue was. I'll go into a little more detail on debugging the authentication at the STS at the end of this module. So let me log in there with an existing account, and next we can look at the completion of the login process. The DB script that comes with the sample code provisions the database with 4 users: admin at globalmantics.com, Alice at globalmantics.com, Bob and Mary at globalmantics.com. All of these have the same password set for demo purposes, and that password is test with a capital T, 123, and 3 exclamation marks. Those same accounts also already exist in my cloud-hosted version of the STS and API. I'll log in as admin here. As soon as I click login there, the STS validates the entered credentials, and then it looks to the user like it just redirects back to your client app and you're done logging in. There are actually several requests that happen in between when the user clicks login at the STS and when it redirects back to your client app. And at that point, the login process is still not yet complete either. Let's take a look at that first batch of requests in Fiddler. First, you can see the form post here for the login form. The response for that form post redirects back to the authorized endpoint again, and you can see it's setting a cookie here. That cookie is to establish a login session at the STS. That session makes it so as long as you keep the browser open, if you were to navigate to a different site and then come back to your app and click login again, the STS would get the session cookie and know that you're already logged in with it, so would not present the login form again. The authorized endpoint would just redirect back to your client redirect URL with a new authorization code. This session is also instrumental in enabling single sign-on. At this point, I don't have that redirect callback route and view in place in the Angular app, so I'll add that shortly. But before I do, let me show the beginnings of the single sign-on capabilities you'll get with an OpenID Connect provider. After I've been redirected back to the client app, I could click Login again, and if you watch the address bar closely, you probably won't see the redirect to the STS because it happens so fast, but you will briefly see it come back into your application with the sign-in callback segment in the URL and a new authorization code. Keep in mind that redirect to the STS means your Angular app completely unloads from memory, and the redirect back to your client app results in a fresh launch of the app. If I navigate to a totally different site, such as Pluralsight, and then back to my spa, when I click login again at that point, you can see I'm still logged in because it did not show a login form. That is all because of the cookie-based authentication session I established on first login with the STS. Now I need to get my callback route and view in place to finish the login process, so let's do that next. As covered earlier in my diagrams of the authorization code flow with Pixie, at the completion of the sign-in redirect and login at the STS will redirect back to the client with an authorization code in the redirect response location header. You can then add code that gets invoked when the callback comes back into the client app to complete the sign-in process. That completion will get a user object populated with the resulting ID and access tokens for calling your APIs, which happens behind the scenes as an API request to the STS token endpoint. That call is made by user manager when you call usermanager.signinRedirectCallback. So the first thing I will add is a method in my auth service named CompleteLogin that can be called by my views. And that method will just call usermanager.signInRedirect callback. That returns a promise that produces a user, which I will handle, set the user property on my auth service, and then return that same user to make it available to the caller if they need it. I'll also have this code fire the login changed observable to any code that is subscribed to it in the application. Now I need to invoke that auth service method from the view component that loads when the callback comes into the app. To do that, I need to add a view component, which I will call signInRedirect callback component. I'll create that here in the home folder. I'll use a code snippet here to stub out a view component quickly that has its UI inline, and I'll make that an empty div. You could maybe show a logging in message or something here, but the login process completes so quickly that you might just want to leave it blank. I'll inject auth service into the constructor, and I'm going to want to route to a different view after the login process completes. So I'll also inject the router here. I'll add a call in the ng-oninit method that invokes the complete login method on the auth service. On completion of the promise that complete login returns, I want to navigate to some other view. I can ignore the user that is returned from the promise because the auth service and user manager already have it cached, and this view does not need to do anything with it. In my promise handler, I'll just navigate to my root view, and I'll use the replace URL option to remove signInRedirect callback component from the back navigation stack. Now I'll need to add my new view component to the declarations of the root module, and then go add a route to it in my routing configuration, with the route segment matching the URL configured for the redirect URI property of the user manager settings. Now I can go to the Angular app, click login, I get redirected to the STS, I log in there, and then I am redirected back to the client app and the login process completes. Let's go look at the series of requests that happened when I did that in Fiddler. Here are the requests we looked at earlier that got us logged in at the STS, including the initial redirect to the authorized endpoint at the STS, followed by the redirect back to the client with the authorization code. Then you see a call to the token endpoint at the STS that is a post with form-encoded parameters in the body. Those parameters include the PXE code verifier, which the STS will hash and compare to the code challenge that was sent with the original redirect to the STS. Then, if I look at the response for the token endpoint call, it contains a JSON payload that contains the ID and access tokens that complete the OIDC login flow. At this point, the user manager in our auth service contains the user object with the tokens that were just returned and can be used to get those tokens to pass them in our calls to our APIs, which I'll focus on a little later in the course, after I talk about a few more things to do with the authentication process. Right now, once I log in, there's no visual indication to the user that they have logged in, and I have no way from our app to log out. Let's fix that. First, I'll go to my root app component that has the login button, and I'll add an ngIf directive to the button and hook that up to the isLoggedIn property that I added earlier. That way, the login button will only show if not logged in. Then I'll add another button that only shows when logged out that lets us log out. I'll also add an ngIf to the buttons for My Projects and Manage Projects, since the user needs to be logged in to go to those pages. Then I also need to add the logout handling. For that, first I'll go back to the auth service and add a logout method that calls usermanager.signoutRedirect. You need to redirect to the STS to log out so that it can invalidate the tokens and the login session. I will also add a method called complete logout and have that call usermanager.signoutRedirect callback. Just like with login, I need to invoke that to complete the logout process. I'll return the promise from signout redirect callback to the caller. Invoking that method will clear the state of the user manager and the user object that it has cached. And I will also set the auth services user property to null when complete logout is called. Then I can go add a method to the app component called logout, and that just delegates and calls the auth service logout method. So that will again result in a redirect to the STS. So once the STS does invalidate the tokens and kill the login session, it redirects back to the post logout redirect URI setting that you configured for the user manager. Like I did with the login redirect, I need to add a component to complete the logout process when the STS redirects back to the app after killing the session. So I will go add another empty view component named signout redirect callback component to the home folder. I'll use a code snippet again to populate the boilerplate code, and we'll put an empty div for the UI, since it will again only be shown for a moment. I'll again inject the auth service and the Angular router into the constructor, and then in ng on init, I will call complete logout on the auth service. In the promise handler for that call, I will then just navigate back to the root view, passing replace URL equals true to remove the signout redirect callback component route from the back navigation stack. Then I just need to add that component to the declarations in the app module and add a route in the routing module to that component with our signout-callback route that was set in the user manager settings. Now, if I go back to the app, I can log in, and when I come back in, the login button is hidden and the logout button shows, as well as the My Projects and Manage Projects menu items. Then if I click logout, I am taken for a moment to the STS, and then it redirects back after killing the authentication session between the client and STS. So now I have login and logout all hooked up and working. Let's finish up this module with a look at a couple of debugging and troubleshooting techniques you should have in your toolbox. One thing I want to show you, even though I am not going into depth on setting up an STS in this course, is how to detect and identify errors in the login process. The most common and frustrating errors to debug when working with an STS are client app configuration errors. Keep in mind that your client configuration on the client side must match up exactly to the client configuration at the STS. That includes each of the URLs you are configuring, as well as the client ID and scopes. Any difference between the configuration values on the client side and those at the STS will result in client configuration errors when you first connect to the STS. The first thing you might get wrong is pretty straightforward when it occurs. If the client ID you configure on the client side does not match a configured client configuration at the STS, you will get an error when you first redirect to the STS telling you it cannot find a matching client configuration. Matching up the client IDs should fix that scenario. One of the more subtle issues is when either of the redirect URLs that are in the client configuration do not match the client configuration at the STS. Those URLs have to match exactly. All it takes is for the URL on one side to have a trailing slash and the URL on the other side not to have the trailing slash, and you can get client configuration errors. How those show up and how you debug them is going to vary from one IDP to another. For Identity Server, they get output to whatever your logging is hooked up to. In the case of my sample code, it is using Serilog to output the logs to the console. So running the STS as a console instead of through IIS Express will give you easy access to these logs. For example, if I just change the client redirect URL to have a trailing slash and leave the STS configuration without that trailing slash, when I go to log in, even though those URLs are semantically the same, they are different in declaration. So I get this client configuration error. Sometimes the client error does not give specific information about what is wrong on the client side. That is because that information could give an attacker more clues than you want and potentially allows them to more quickly compromise your system. But the STS should be logging all the details of what is going on at the STS somewhere that is accessible to you. So in this case, if I go look at the logs for Identity Server, you can see here it is explicitly telling me that my client redirect URL is wrong. If I fix that, I am back in business. One other thing you should know how to do is inspect the contents of the JOT tokens that the STS returns at the end of the login process. So let's look at that next. Another thing you may want to do from time to time for troubleshooting purposes is to inspect the JOT tokens that are being issued and passed as part of your authentication and authorization flows. You can get to the tokens that are issued as part of the login flow by using the browser debugging tools. If I go to the app and log in, when it completes the login process, you can go to the Browser Debugger Application tab. Here you can select the session storage, and you can see an entry for my STS URL. If I select that, you can see the contents down below. I'll grab the value for the ID token and copy it to the clipboard. Then I can fire up another tab in the browser and go to jwt.io. In that page, I can paste in what is on the clipboard, and then just need to remove the quotes and the ID token property name at the beginning. Then you can see that jwt.io decoded the token and shows you the contained claims. Remember that your JOT tokens are not encrypted, but they are digitally signed to prevent tampering and encoded as base64 for transmission. In the ID token, you can see some of the values here include not before or NBF. This is a JSON timestamp for the time the token was issued. Expiration is self-explanatory, also encoded as a JSON timestamp. Issuer, this is an identifier for the IDP that you are using. Audience, this is the client ID of the auth2 relying party or client application. Subject identifier or sub, this is a unique end-user identifier within the IDP, and a few other properties that I won't go into. Then I can do the same thing with the access token. I'll go grab the access token property and copy to the clipboard, and then go paste it into jot.io again, cleaning off the quotes and the property name. In there, you can see that there is similar structure, but this contains claims that your backend APIs need to authenticate and authorize the calls to the API. You can see this too includes claims for not before, expiration, issuer, as well as the client ID and subject. But it also includes the audience parameter, which includes the name of the API resource the token grants access to, as well as the scopes that were requested and approved by the STS. So if you are ever having trouble getting the communication between a client app, backend resource, and your STS set up correctly, this is a useful tool to know exactly what is ending up in the tokens issued and passed to the APIs. How users get defined and saved with your STS is not part of the OpenID Connect protocol. And in many business environments where an STS will be used, you won't allow users to self-register anyway. There will often be a process that involves having an admin invite a user to the app, which takes care of creating and configuring the user. Even if you allow self-registration, how you set that up is going to be specific to the STS you are using and specific to your requirements for what the experience is for self-registration and where that gets deployed. So for the demos in this course, I am just using a set of pre-configured users that are defined in the database that my Identity Server instance is using. If you wanted to support self-registration, password resets, and those kinds of features in the login process, you could just add additional pages into the Identity Server STS project to accomplish that. Or if you're using an external STS, you would just go into the documentation for that IDP to figure it out. but I won't be going into any detail on that since it is STS specific and server-side coding that is not the focus of this course. In this module, I covered the details of the OpenID Connect protocol that you should know to get started using it, including why you should use it, what JOT tokens are, and then a good detailed walkthrough of the protocol flows. I showed you how to get the sample code up and running on your machine, and then I walked you through adding the right code to your Angular app to be able to log in and log out with an OpenID Connect identity provider. I showed you how to add OIDC client to your application and configure the user manager for connecting to an OIDC STS. I showed adding a login button and having that trigger the login process, and then handle the callback from the STS to complete the login process. You saw how to allow any code in the application to know if the user is signed in, and then I used that to hide and show login and logout buttons and navigation links in the root UI menu. Then we looked at how to log out with the OIDC STS and handle the callback from that process as well. Finally, I showed a couple debugging techniques for understanding what is happening in the communications with the STS during the login and logout process, as well as being able to inspect the JOT tokens issued by the STS if needed. In the next module, I show how to connect to a different OIDC provider, specifically auth2, so that you can see the similarities and differences in doing so. So I'll see you on the other side. Hi, this is Brian Noyes. In this module,